to this point, we have been looking at our trig functions defined in two different ways. First, we've seen them defined as the ratios of the sides in a right triangle related to the one of the acute angles in the triangle. And then we've also looked at them in terms of the coordinates of points on the unit circle. And so we want to try to look at our trig functions in a third way. More specifically, we want to think of our trig functions as kind of like algebraic functions, kind of like our polynomials, our quadratic functions, rational functions, exponential and logarithmic functions, stuff like that. So we can apply what we know of those algebraic functions to our trig functions here. So to do that, we're just going to start looking at sine and cosine here. And so first, let's looking at sine. We want to find a relationship between the rotation around the circle and how that determines what the sine value is going to be. So if we remember on the unit circle, the sine value is the y coordinate, right? And so if we have an angle of 0 radians, then the y coordinate is 0 because the coordinate is 1, 0. So the y value is 0. And so we want to see what happens as we go around that circle. And so with this little illustration here, I want to look at as we rotate around the unit circle. And we remember with rotation, we can go around in both clockwise and counterclockwise directions. We can look at positive angles and negative angles. And there's no limitation to it. But for this particular graph here, I've only limited it to us rotating between 0 and 2 pi. So 2 pi would be about 6.28 radians. And so if I go a step further, notice it jumps back to 0 radians. But technically, it could continue rotating past 6.2 pi forever, right? The angle could get bigger and bigger and bigger. And we can also do that in the negative direction. But again, I haven't set that up here. But so anyway, as we rotate around the circle, follow what happens to the y coordinates. Okay, so right now, as we go around the circle, we're going to start with 0 radians, and the y coordinate is 0. Okay, as we rotate around, so we're going to rotate 90 degrees up to the top. So that's pi over 2 radians, or about 1.57 radians. Now the y coordinate is a 1. If we keep rotating to the left side of the circle, we'll stop at pi. Okay, and at pi, the y coordinate's 0 again. And if we rotate to the bottom, that's 3 pi over 2, which is about 4.71 radians. Then again, now we get a negative 1 for our y coordinate. And if we rotate back to 2 pi, that puts us right back at our starting point, basically. So the y coordinate is 0. Okay, so as we rotate around from 0 to 2 pi radians, we're going to see the y values go from 0 to 1, back to 0, down to negative 1, and then they'll come back up to 0. And as we go around the circle over and over and over again, we'll see that pattern. It goes 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. And it's going to keep doing that. Okay, so what does that look like if we take that and we think of the 0 to 2 pi, the rotation, as an x value along the x-axis, and we take the y coordinates of the point on the unit circle as the actual y value. Okay, so for a 0 angle, 0 radians, and a 0 y coordinate, that would correspond to 0 for x and 0 for y. So the sine function, it's kind of hard to see here because they overlap each other, but the sine function has 0, 0. So 0, 0. The first 0 is the x value, which comes from the theta angle of rotation. And the second 0 comes from the y coordinate on the unit circle. Okay, so let's track around here again as we start rotating around. So again, if you see as we're going around the circle, the y coordinates go up, right? They go from 0, and they're going to rotate upwards to 1. And so we're going to see it continue going. And I've kind of showed these little dotted lines here to see that the height of our sine function is the same as the height of the point on the circle. Okay. So right now, if you look at the point that I have for our sine function, the x-coordinate is 1.31, and that comes from the angle of 1.31 radians. And the y-coordinate is 0.97, which is kind of hard to see here, but that comes from the y-coordinate on the unit circle. All right. So let me keep rotating around. Once we hit the top of the unit circle, right, the top of the unit circle is 1.57 radians, and the coordinate at the top of the unit circle has a y-coordinate of a 1. And so we see that paired together for our sine function. The x value is 1.47. So we're moving along the x-axis over here to 1.57, and the y-coordinate is a 1. And so if we keep going, it's going to go from 1. Remember our pattern, it's going to go from 1, and then it's going to go down to 0. And that's going to take a distance of pi rotation. So that's pi along the x-axis. So 3.14 in the x direction. And then we're back to the 0 y-coordinate. And then it's going to go negative. If you remember, it's going to go all the way down to -1. And it's going to take about 3 pi over 2, so about 4.71 radians. And it'll be down at the bottom of the circle, which is the bottom of this sine graph. And then we're going to continue rotating around the circle, and we're going to end up at 6.28, so 2 pi, and that is again back to 0. And so as we rotate around the circle, this picture almost looks like we're unrolling. It's technically not what we're doing, but it looks like kind of like you're almost unrolling the sine function, okay? And so we're kind of unraveling it a little bit, so to speak. So the top half of that sine graph corresponds to the top half of the unit circle. The bottom half of the sine graph corresponds to the bottom half of the circle. Okay. So again, the x-coordinates for the sine function correspond, the 6.28 in this case, corresponds to the angle of rotation, whereas the 0 value corresponds to the y-coordinate on the unit circle. Okay. Now, remember, if we kept going around the unit circle, we would continue to repeat this pattern, okay? So at the end of our graph here, we're at 6.28, 0. If I kept rotating as as that 6.28 increases towards 7 and 8 and 9 and so forth, the graph is going to go up to 1, back down to -1, back up to 0. And then it's going to go up to 1, down to -1, back up to 0. So it's going to keep doing this cyclic or repetitive nature, which we could call a periodic nature. And so this idea of a periodic or period relates to how long this graph has to travel before it starts to repeat. Okay, and so what we're seeing here, this graph from x equals 0 to x equals 6.28, that is the length of one period. So if I go anywhere beyond that one period, I start to repeat this same shape again, this kind of wave pattern. Okay, so for sine, the length of one period of the sine graph is 2 pi, which should hopefully again make sense because we're just rotating around the unit circle. That's one revolution around is 2 pi. Now, in terms of domain and range, remember those are things we talked about with our quadratic functions and stuff like that. Again, because I can rotate indefinitely in both the negative and positive directions, so clockwise and counterclockwise, the domain for this function is technically going to be from negative infinity to positive infinity. Okay, so it will continue repeating this up and down kind of wave shape if you go as far left as you can, so to negative infinity in the x direction, or to positive infinity in the x direction. It will keep repeating that. Okay. So that's the whole function, negative infinity to positive infinity. One period is just from 0 to 2 pi. Okay. And then we also have a range. So in the range, if you see this function, the highest it ever goes is 1, and the lowest it ever goes is -1. And that's because they're based off the y-coordinates on the circle. And so our range would be from -1 to +1. Okay, so that's our sine function. Let me reset this, and we'll look at cosine. So we're going to do the same thing. We're going to rotate around the circle, so from 0 radians all the way around to 2 pi. And this time we're going to follow the x-coordinates on the circle. Okay. So remember, with cosine, cosine is the x-coordinates, so it starts at 1. As we rotate around, the x-coordinate is going to go to 0, and then we're going to rotate around to pi, and we're going to have an x-coordinate of -1. And then we're going to rotate to the bottom of the circle at 3 pi over 2, and we're going to have an x-coordinate of 0 again. And then we go back to the starting point, and we'll have an x-coordinate of 1. Okay, so for cosine, we go 1, 0, -1, 0, +1. And it's going to keep, again, repeating that pattern. Okay, so let's see what that looks like if we kind of unroll it across the x-axis. Okay, so again, our initial starting point is 0 radians, so that's our x value, and 1 for the y coordinate. So that's the 1 is the x coordinate on the circle, but it's going to be the y value as a function. Okay, so our first coordinate is 0, 1. 0 from the angle, 1 from the x value. Okay, so as we rotate, we're going to start at 0. We're going to rotate to the top of the circle, which has an x-coordinate of 0. That's so pi over 2, comma 0. We're going to continue rotating until we get to the left edge of the circle, which has an x-coordinate of -1. So that's pi rotation, so 3.14, comma -1. Then we're going to rotate to the bottom of the circle. That's 3 pi over 2, which is about 4.71. And again, the x-coordinate there is 0. And then we're going to rotate all the way till we get till 2 pi. And again, at 2 pi, or 6.28, the x-coordinate is again a 1. Okay, and so we see it's sort of a similar wave shape, but a little different section of it. But this is what one period of cosine looks like. And one period is from 0 to 2 pi, just like it was for sine. So cosine, both sine and cosine have a period length of 0 to 2 pi, because that's really just going one revolution around the circle. Okay. And just like sine, we could take this cosine graph. Notice here at 2 pi, it's at the peak of the graph. It's going to go down to -1 and back up to 1, and then down to -1 and back up to 1. It's going to keep doing that repetitive pattern because we're just going around and around and around and around. Okay, so one period is 0 to 2 pi. It will technically continue forever to -infinity and +infinity. And so the domain for the cosine function is -infinity to +infinity, just like sine. And same thing with the range, because the highest this graph ever goes is 1, the lowest it ever goes is -1, and therefore its range, the range of the cosine function, is -1 to +1. Okay, so now we have 3 ways to picture and use our trig functions. We can think of them as right triangle, the ratios of the sides of right triangles. We can think of them as the coordinates on unit circles. And then we can think of them as these actual algebraic functions. Okay, they're technically transcendental functions, but we can still think of them in the same way. So we can talk about, x-intercepts, y-intercepts, asymptotes, stuff like that. Okay, and so that's kind of where we're going to be heading next. But for now, we just want to know what sine and cosine look like.